Hey, welcome to this online demonstration to give you instruction and step-by-step procedures on how to create a group frequency distribution in support of part 2 of our first class assignment. Now, what we have here in column A is data from our class census survey, and this is the length of foot variable. These are your foot lengths in centimeters. Now, what we're going to do is create a group frequency distribution with this data. We first have to decide on the number of intervals, the number of class intervals that we're going to be using, and also the width of the intervals before we actually get started to create the actual group frequency distribution here. Now, in order to do this, we need to get three pieces of information to begin this process. I'm going to start with actually finding the minimum value in the data set, the maximum value in the data set, also the number of scores in our data set, number of observations. That way, we can use that to actually assess both the intervals and the interval width. So let's begin with the minimum value. Now, of course, we could just simply scan the data, but we have a large data set here of close to 100 values. And so we're going to let Excel do that for us. Now, Excel has two commands that will provide us with minimum and maximum values, the minimum, min command, and the max command. Let's begin by finding the smallest value in our data set. We're going to say equals, and then we're going to use the command min, which returns the smallest number in the data set. Parentheses, now we can highlight the column with all the data in it. That's column A. It automatically populates the cell with the column A:, and then we end with a parentheses. That gives us 14, which is the lowest value in the data set. Now let's do the same thing, but this time for the maximum value. Equals max, parentheses, highlight column A, populates the command, and we find out 31 is the highest value in the data set. Now we want to know how many observations there are in the data set. We could scan the data to do the count, but if there were some missing values in the data set, that might be confusing. So there is a command using the COUNTIF command that will look for every cell that is populated in our range of scores, in this case in column A. And this command is the following. It's equals COUNTIF, parentheses, the range of scores, comma. Now it's going to be double quotation mark, the less than, greater than sign, double quotation mark, and parentheses. Right now, that would actually return the value of the number of cells in column A that has a value in it. Now, of course, you can see in column A, the first column actually has the variable label there, foot length, and we don't want to count that. So we want to use that COUNTIF command, and we're going to subtract 1 from that, which gives us an n, number of observations, of 92. Now, we know that there's 92 scores in our data set. Now, to decide how many intervals we're going to use for this group frequency distribution, what we're going to use is 2 to the power of k guideline. Now, I have here the values of k incrementing by 1 here, and now I'm going to just add the formula that would actually calculate 2 to the power of k. That would be 2. And then we're going to use the caret symbol, which is your exponent. And then we'll click on the value of k that's listed in column n here. And to the power of 1 is 2. Now I'm just going to use the file handle to go right down and increment the value of k by 1 each time. And of course, what we're looking for here is the first value of 2 to the power of k that exceeds our value of n here of 92. And we see that 128 is 2 to the power of 7. Our guideline is suggesting that we use 7 intervals for this group frequency distribution. Now that we know how many intervals we're going to use, the minimum and maximum values in our data set, we can now establish the width of the intervals that we're going to be using. Recall that the formula for that is going to be the high value in the data set minus the low value over the number of intervals we're planning to use. That will be 31 minus 14 divided by 7. Now, of course, we can have Excel do all the mathematical work for us. So we'll say equals, parentheses, the maximum value of 31 minus the minimum value of 14, parentheses, divide sign in Excel is the /, and of course, that's going to be divided by 7. And what we get is a value of 2.4 and a bunch of other decimal places. And as we talked about in class, what we try to do is simplify the mathiness of these frequency distributions by actually using multiples of 5 here. So in this particular instance, we're going to use 2.5 as our interval width. Now we're ready to begin to populate the lower and upper values of our intervals that we've come up with. Let's begin with the first one. Now, the first interval will include the lowest value in our data set, which happens to be 14. So let's start with 14 as our value here. Now, we're going to increment 14 by our interval width, which is going to be 14 plus 2.5 there. Now, we could have just done the math ourselves, but let's let Excel do it for us. Now, I'm just going to put a $ in here. So we'll be using absolute cell referencing as we move further down here. And what we're going to do, of course, because it does say that we're taking the lower value and the upper value just under this 16.5 value, our next lower value of the interval is going to be that upper value right there. And then we can just slide this down here and we can let Excel just populate the rest of our upper and lower values that we're going to be using. Now, we're ready to start counting. In Excel, when we're using a group frequency distribution, instead of using the COUNTIF command, we're going to be using the COUNTIFs command, plural. What that does is allow us to use multiple criterions. And this is what the syntax of the statement looks like. Equals COUNTIFs. We start with our first criteria. And of course, we're still using this data from column A. Now, we are going to tell Excel that we want values that are greater than or equal to a particular cell here, and that would be our lower value cell. Notice that I'm using the and sign before the clicking on the cell, and that just informs Excel that the next values that come up are actually going to be that cell address there. Now that tells Excel that all values are going to be greater than or equal to 14. Now we have to tell Excel that we also want all these values, along with being greater than or equal to 14, to be less than 16.5. So we're going to put a comma here. Once again, tell Excel to look at the data in column A, and then we will add the criteria that we're going to be using, double quotation marks, less than, double quotation mark, and in this case, it's going to be the and sign. Click on that cell with 16.5 in it, end it with bracket, and we find out that there's 2 observations in our data set that are somewhere between 14 and 16.5. Now what we're going to do is use the file handle to slide down to the bottom of our table here. And it looks like a nicely symmetrical distribution of people's foot length. Okay, let's make sure we have all the values in our data set. So if we count up all these values, it should equal 92. Now we can just go to the auto sum icon up on the ribbon here, click on it. It automatically populates it with the sum statement and highlights all the values that will be summed. We just have to press enter and we find out indeed we've got 92. Now what we're ready to do is calculate the percentage for each value in our data set like we've done in the other versions of frequency distributions that I've shown you. So we're going to use the equal sign, click on the frequency value, divided by the total number of scores. We're going to add the dollar symbol in front of the 9 to make it an absolute cell reference so that when we use a file handle, it will remain glued to that value of 92. Now this is a proportion. To actually change this proportion to a percentage, we click on the ribbon, this icon here, turns it into a percentage. Now we're ready to use the file handle to slide down to the end of the column here, and now we've got our percentages. Let us just add our cumulative percentage now. I am just going to make a little adjustment to our table here in order so that we don't get an error. So to actually do the cumulative percentage here, I'm going to start with an equal sign, and we're going to add the value, the cumulative value above, plus the current percentage there to get the cumulative percentage. And so we're going to say click up above, the cell above, plus the percent of the current interval, and that will give us 2%. And then we can slide down right to the bottom of the table. And of course, the last value in our table is 100%. We've done this correct. And there you go. You've got your group frequency distribution. Now there's one thing that we could add to this that would be very helpful, especially if we are going to be creating a histogram or in your case a frequency polygon. We'll want to actually calculate the midpoint of each interval. So the midpoint, when we're using the lower interval and upper just under, is simply going to be the lower interval value plus the upper under value, parentheses, divided by 2. And then we will just slide this down. And we've got midpoints for this as well here. So that's it. That's your group frequency distribution from start to finish. Good luck on the assignment. Bye for now.